Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides practice with using hypothesis testing for linear correlation. Let's get started. So here we have an example problem involving lemons and car crashes. Lemons and car crashes. So we have the data set that you see here, and this data set is actually found in our StatCrunch group. So if you want to follow along in StatCrunch, feel free, go to StatCrunch and dump this data from our group there into StatCrunch and follow along as we look at the answers to these questions. What does a scatter plot of the data look like? What is the linear correlation coefficient? What is the test statistic? What is the p-value? And then, is there sufficient evidence at the 5% significance level to conclude linear correlation? And then finally, do the results suggest that imported lemons cause car crash fatalities? So let's look at these questions one at a time. So if you take the data, and you put that there in a StatCrunch, it's pretty easy to make a scatter plot. Just go to Stat, Regression, Simple Linear. Noticing I'm not going to graph scatter plot. That's because I know I'm going to need regression analysis output, and so I get the scatter plot from the regression analysis, so let's just go there. It just makes it easier. So I go to Stat, Regression, Simple Linear, and then in the options window I select my data columns, press Compute, and then I advance to the second page of those results, and then I find that the answer here is answer option C. So if you want to practice this in StatCrunch, feel free, pause the video, go check it out, see if you can get the same thing. You should be able to pretty easily. Remember, you can always adjust your plot area and axis values as you need to in order to find the proper match with your answer options. Next question asked for the linear correlation coefficient. So I just flip back from the scatter plot to my regression analysis results. Here's what it looks like. So I'm just going to read the value right there off the results window. The linear correlation coefficient right here at the top, negative 0.95896264. And I can round that to as many decimal places as they ask. What is the test statistic? Okay, well, the true test statistic is located here in your parameter estimates table. So negative 5.858. A p-value right next door. Notice that we're using the values for the slope parameter and not the intercept. Very important. Fifth question was, at the 5% significance level, is there sufficient evidence to conclude linear correlation? This is pretty simple to work out too. So we'll use the critical value to answer the question. So here's our table of critical R values. And notice we've got 5 pairs of data, so our sample size is 5. At the 5% significance level, where those two intersect, is 0.878. So here we've got 5 for our sample size, 0.05 for alpha, where those two intersect, that's the 0.878. So we compare this with the R value we get from our data. The R value we get from our data, 0.959. So yes, we do clear the bar. We have linear correlation. Sometimes you're asked in a problem to provide critical values. Remember that the table that you see there for the critical R values is listing only the positive values. So if you're conducting a two-tailed test, which typically you will be, because they don't specify positive or negative linear correlation, it's just general linear correlation, then you're going to have 2 critical values. One's going to be positive and one's going to be negative. The other way to get the answer here is to compare the p-value with alpha. So our p-value from our table that we saw there with our results from StatCrunch, 0.0099, compare that with 5%, we're well inside that threshold. So because the p-value fits inside alpha, we have linear correlation. Either way, there is sufficient evidence to conclude linear correlation between these two variables. Now, do the results suggest that importing lemons causes car crash fatalities? Well, what say you? Do lemons cause car crashes? Or car crash fatalities? So it's people who die in car crashes. Well, if you answered yes to that question, you better not be a hypocrite eating lemons because you're causing people to die. Actually, correlation never implies causation. We saw this in a previous mini lecture. It was true then, and it's true now. Correlation just means there's an association of some type between your variables. So no, imported lemons do not cause car crash fatalities. That's not what the data are saying here. Well, we do have a pretty good linear correlation coefficient. I mean, perfect positive linear correlation is 1. We're at 0.959. So we're doing pretty good. So whatever association you have between the weights of imported lemons and car crash fatalities, it's got to be a pretty good one. What do you think that relationship might be? What's the relationship between lemon imports and car crash fatalities? Yeah, if you want more time to think about this, feel free to stop the video. Otherwise, take a look at your data. Look what's going on. Okay, so as we go forward in time, lemon imports are coming up, but the crash fatality rate, so basically the number of people that die in car crashes, is going down. So what might connect the two together? Well, if you think about this, you should be able to see that the answer is the seasonal rhythms, and they're in sync. So when would lemon imports actually go up? They'd go up in the winter, because that's when the growing season for lemons in this country is substantially reduced or eliminated. So we're not going to be growing as much lemons in this country during the winter because it gets too cold, and therefore we're going to import them from countries that are in much warmer climates, like Mexico, for example. So in the winter, as winter moves on, we're going to import more lemons. Well, that makes sense too for the car crash fatalities. As winter goes on, you get fewer people dying in car crashes. Now, on the surface, that might not make sense to some people because they're thinking, wait a minute, snow and ice on the road? Shouldn't there be more crashes and people dying in car crashes? You would think that would be true. But actually, if you look at the data for, all year round, you find that the fatality rate is higher in the summer than it is in the winter. And that's because in the winter, people know the roads are slick. They tend to be more cautious. They tend not to push that envelope so much. But in the winter, when all the roads are dry, yeah, they're more likely to push that envelope. And it's when you push the envelope that you get into an accident and people die. So this actually makes sense if you think about it. The lemon imports going up as the car crash fatalities go down. The relationship between the variables is that their seasonal rhythms are in sync. That brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.